Hello everyone, today we are going to discuss about mathematical representation of AM double sideband suppressed carrier, and also we are going to discuss generation of AM double sideband suppressed carrier using balanced FET modulator. Myself Dr. Arun. So in this video we are going to discuss this particular two topics. So one is called mathematical representation of AM double sideband suppressed carrier wave. To generate a double sideband suppressed carrier signal, we need two input signal. One is message, another one is carrier signal. By using product modulator or balance modulator, we are able to generate a double sideband suppressed carrier signal. So the VM of t is called message signal and VC of t is called carrier signal. You can see the S of t is called double sideband suppressed carrier signal. Just we are multiplying VM of t and VC of t. The resultant output will be double sideband suppressed carrier signal. So the waveforms are represented, the first waveform representing message signal, the second waveform representing the carrier signal, and the third one representing the double sideband suppressed carrier signal. So you can compare this double sideband suppressed carrier signal with double sideband full carrier wave. The waveform, there is a difference is there. So the corresponding spectrums also represented. In the double sideband suppressed carrier, the center point, the carrier frequency is removed. While generating this amplitude modulated signal, only upper sideband and lower sideband is available. The carrier is removed from the modulated signal. So mathematically we can prove here the Vm of t is equal to Vc cos omega Ct. Vc of t, Vc cos omega Ct. The first one is message signal, the second one is the carrier signal. Multiply both the signals together. So final output is S of t is equal to Vc Vm of t divided by 2 and cos omega c plus omega m of t plus cos omega c minus omega m of t. The two different frequency components are available. One is called upper sideband, another one is lower sideband. The carrier frequency is missing in this particular equation. So that means after multiplication of the two signal, you will get only upper sideband and lower sideband. The corresponding spectrum consists of upper sideband and lower sideband, dotted line representing the suppressed carrier. Generation of a double sideband suppressed. How to generate this AM double sideband suppressed carrier signal? What are all the circuit diagrams available, or what are all the methods available to generate AM double sideband suppressed carrier? One is balanced field effect transistor modulator. Another one is diode ring modulator. The two different modulators are available to generate double sideband suppressed carrier signal. Here, if you want to generate this double sideband suppressed carrier signal or any device, if you want to achieve a modulation process, we need specifically a non-linear device. So the non-linear device like diode transistor or field effect transistors are utilized to generate this type of modulated signals. Here the balanced FET modulator, the circuit diagram is available. In the balanced modulator are built-in blocks from which a wide variety of frequency mixer, modulator and demodulator. The two matched field effect transistors are connected in differential amplifier mode and act as a balanced modulator. Here you can see the corresponding carrier signal is applied here and also the modulating signal is applied in this particular point. So the net output here we are going to take by using the transformer 3 double sideband suppressed carrier signal. So this is the corresponding model waveform of double sideband suppressed carrier signal. So here the two different modes of operation is available. One is called only applying the carrier signal, and the second mode of operation applying both message signal and carrier signal. If you are going to apply only carrier signal at the first mode, here what will happen, because of this carrier signal in phase to the both corresponding field effect transistors are fed to the gate, it will generate a equal drain current and also opposite in direction. So that's why it will cancel together, the net output is 0. So in the first mode of operation, we are going to apply only the carrier signal. The message signal is 0. So this carrier signal we are applying through this center tapped transformer. Both the currents are equal towards the gate VGS1 and VGS2. So the both potentials across corresponding gate is equal. The net output of the field effect transistor ID1 and ID2 are equal, but opposite in direction, the net output is 0. Then we can conclude while applying the carrier signal, it is completely removed. When we are going to apply a modulating signal along with the carrier signal, in this particular situation, the modulating signal is applied through this both the field effect transistors 180 degree out of phase because we have a center tapped transformer. Here the cumulative effect is Vc plus Vm for the first field effect transistor and Vc minus Vm for the second field effect transistor. Based on this particular potential difference Vc plus Vm and Vc minus Vm, the drain current will be different. So the net output will be completely depends upon the modulating signal amplitude. Based on that modulating signal amplitude, you will get a corresponding double sideband suppressed carrier modulated output. So here VGS1 is equal to Vc plus Vm and VGS2 equal to Vc minus Vm. So you know the drain current formula I0 plus A VGS1 plus B VGS1 square. Similar manner for ID2. So in this particular two equations we can substitute VGS1 and VGS2, and the difference between these two currents, the net effect will be obviously double sideband suppressed carrier signal only. So in this final equation you can see after substitution and simplification, the first component is omega m of t representing message. The second component is omega c minus omega m. This will represent lower sideband. Omega c plus omega m upper sideband. So we need upper sideband and also lower sideband. This message signal is removed by using filter after performing the modulation. Then net output consists of double sideband suppressed carrier signal. Disadvantages of field effect balance modulator: 100% of carrier suppression is not possible because both FET must have identical characteristics and the transformer center tab must be exactly at the center of the windings. So because of slight mismatch in that particular circuit and characteristics of the FET, it will generate a corresponding carrier signal. So in that particular situation, the final conclusion what they are specifying, it will suppress heavily. The carrier is suppressed heavily, not 100%. Thank you for watching this video. So if you like this video, like, comment and share, subscribe. Thank you. We will meet again with some other video in this particular subject. Thank you all.